Okay, November 21, paper 1, variant 3. Question 1. Teacher asks a student to measure the volume of a pencil sharpener. Which piece of apparatus would not be useful? Okay, yes, it is the balance. You don't need a balance. You do not need the balance to find the volume. Question 2. Graph shows the speed. Okay, the speed of what's a displacement can? A displacement can is it's like a can. Okay, it's like a beaker or whatever that can measure. It's like a measuring cylinder. Okay, it's the same concept of a measuring cylinder. You can find the change in the liquid volume. Okay, the change in the displaced water, the displaced liquid. Okay, the changed liquid. Okay. In question 2, graph shows speed time graph. Okay, which distance time graph represents the speed time? Which distance time graph is the same as the speed time graph? What's happening to the speed? Initially, the speed was increasing. The speed was increasing. Which of these graphs would show the increasing speed? A. Okay, a lot of you are saying A. Could it be C? Okay, so you've canceled out B and D. Yes, you've canceled out B and D because they are decreasing speeds. Could it be C? That's the question. Is it A or is it C? Is it A or is it C? And how should I find the difference between A and C? Okay, very simply, all you need to do is what? All you need to do is find the distance traveled. How can I find the distance traveled? It would be the area under the graph, half times base times height. So half times 4 times 6 is 12. After a time of 4 seconds, it had reached a distance of 12 meters, which is A. Okay, half times base times height to find the total distance traveled. Okay, and A would have a total distance of 12 meters. Any questions? Question 3. Student uses a force meter, okay, to measure the weights of some masses. He puts his measurements in the table. Which row is correctly recorded? Which row is correctly recorded? It would definitely be A. Yes. Why is it A? Why can it, Mr. B could be right? No, B is not right. Why? Because the mass is in grams. You cannot multiply 5 times 10 or 9.8. It would be wrong. You need to divide by 1,000 and then multiply by 9.8. So A is correct, yes. 1 times 9.8 or times 10, okay, would be around 10 newtons. Which substance in the table has the lowest density? How can I calculate the density? Density equals mass over volume. Mass over volume. So you'll simply calculate 1.2 divided by 1, 1.2. 1.5 divided by 1, 1.5. 1.8 divided by 2, 0.9. 2 divided by 2 is 1. Okay, so the least density is C. Quite simple. Quite simple. Question 4. Question 5. Okay, moment. One of the questions which you usually get wrong. Okay, moment. Especially if it has 3 forces. I know you are not used to solving moment questions with 3 forces. Usually we're used to solving moment questions with only 2 forces. What happens if I have 3 forces? I have to differentiate between each force. You must, okay, you must find out which force causes a clockwise moment and which force causes an anti-clockwise moment. Why? Because this beam is now balanced. It's in equilibrium. It is in equilibrium. So you need to find which force causes clockwise moment and which force causes an anti-clockwise moment to write down the equation clockwise moment equals anti-clockwise moment. First force, the 4 newtons. Would it cause a clockwise moment or an anti-clockwise moment? the 4 newtons. This is an anti-clockwise moment. Yes, this is an anti-clockwise moment. But what about the 6 Newton? The 6 Newton force. It's also an anti-clockwise moment. Okay, it also causes an anti-clockwise moment, leaving the 5 Newton force to cause a clockwise moment. So we have 2 anti-clockwise moments and only 1 clockwise moment. What should I do? I should write the equation. Clockwise moment equals anti-clockwise moment. Clockwise, the only one, okay? The only clockwise moment is the 5 Newton. So 5 times the distance. I do not know the distance, okay? You do not know the distance to the pivot. So just write down 5 times d, 5 times distance, 5 times the perpendicular distance equals, we have 2 anti-clockwise moments. 4 times the distance to the pivot. What's the distance to the pivot? It's 30 centimeters. So 4 times 30. Plus 6 times the distance to the pivot, which is 60 times 50 is 10. So 6 times 10. Again, 50. Distance here is 10 centimeters. 6 times 10. Can I solve for the distance? Yes, I can solve for the distance. 4 times 30 is 120 plus 60, which would be 180. So d times 5 is 180. How can I find the distance? All I need to do is divide by 5. All you need to do is divide by 5. 180 divided by 5 is what? 180 divided by 5 is 36. Is 36. You do not have 36 as one of the answers. You do not have 36 as one of the answers. What should you do? At which point on the beam is the 5 Newton force acting? Okay, let me use another color. It is now acting at a distance. It's now acting at the distance of what? Of 36 centimeters. From which point? From the 50 centimeter mark. From the 50 centimeter mark, you added 36. So basically 50 plus 36 would be, yes, 86 centimeters. Okay, 36 centimeters from the pivot. You just added, okay, 50 plus 36, which would be 86 centimeters. This is quite a difficult question, okay? Please make sure that you can solve it, okay? Just solve it once or twice again. Make sure that you can solve it, okay? Because apparently, okay, I'm guessing that you might have one of these questions in your final exam. Just guessing. You might have one of these questions, a moment question involving 3 forces, okay? If you have a moment question involving 3 forces, you have to write down the equation clockwise equals anti-clockwise. Clockwise moment equals the anti-clockwise moment. Okay? Hmm. Yeah. Any questions? Okay, yeah, moving on. Question 6. Spacecraft is traveling in space with no resultant force and no resultant moment. Which statement about the spacecraft is correct? Yeah, no resultant force and no resultant moment. Zero force and zero resultant force, zero resultant moment means it is in equilibrium. Yes, it's in equilibrium. Yeah, question 7. Weightlifter picks up a stone and places it on a shelf. Which situation requires the greatest power? The greatest power. يلا يا شباب. Which situation requires the greatest power? Definitely. Yes, it would be B. Why is it B? Hmm. Why is it B? Because it's the largest force and the longest distance. Okay. Electrical energy, okay, may be obtained from nuclear fission. In which order is the energy transferred in the process? Nuclear fission. Nuclear fuel. Can it go directly into a generator? No, cannot go direct. Nuclear fuel into a reactor, okay, and then generator, no, and then the turbines, and then the generator, yes. Okay, turbines rotate the generator. So it is D, 8D. Hmm. Yeah. Question 9. A person lifts a book from the floor, okay, to a shelf. It falls to the floor and a second person lifts it back. Which statement must be correct? Which of these statements must be correct, يا شباب? Second person does the same work as the first person. Is this correct? Yes, it is. Okay. Yes, it is correct. Why? The same book. It's the same book being lifted the same distance. So the same force is being applied over the same distance. So it's the same work done. Okay. It is correct. Question 10. Man attached to an elastic cord. Okay. The man jumps from the platform. He falls 60 meters before starting to rise. The length of the unextended The length of the unextended cord is 30 meters. The diagram shows four successive stages in which, okay, listen up, in which position is elastic energy and kinetic energy present. Okay. 9 was A. Okay. Okay. 9 is A. Yes. 10. In which position does he have some elastic energy and some kinetic energy? In A, definitely not. He's not moving yet. Okay. In B, okay, in B, he has some kinetic energy, but does he have any elastic energy? Does the spring or is the cord extended? Okay. Is it extended any further than its original length? No, it's not extended. Okay. It's only at its original length. So no elastic energy. Okay, no elastic energy is in the cord. No elastic energy is in the cord. There is kinetic energy. The man has some kinetic, but the cord does not have yet any elastic energy. Is it C or is it D? Is it C or is it D? They both seem very promising. C and D, they both seem very promising, but D is wrong. Why is D wrong? Why is D wrong? He falls 60 meters before starting to rise again. Okay, so at a length of 60 meters, what happens to the man? He stops and then he starts to get pulled back up. Again, at the length of 60 meters, what happens to the man? He stops. Kinetic energy is uh, zero. The kinetic energy is zero at D. Okay, at this position, his kinetic energy is zero. So this cannot be right. Okay, the only right answer would be C. Why is it C? Because at this position, he still has some kinetic energy. He's still moving downwards, and okay, and the cord is still being pulled. It has some elastic potential energy. It's being pulled in C. Okay, C is the only right answer. Okay. Okay. Yeah. Question 11. Liquid is stored in a tank. The area of the base of the tank is 2.2 meters squared. And the pressure at the base due to the liquid is 1500 pascals. What is the weight of the liquid? How can I find the weight? It's the force. Pressure. Well, pressure equals force over area. Can I find the force? Force equals pressure times area. The pressure is 15,000 pascals times the area, 2.2. So it's going to be D. That's it. Pressure equals force over area, or force equals pressure times area. Multiply them. That's it. Yeah. Question 12. Liquid is evaporating. The liquid is not boiling. It's not boiling. Which statement about the liquid is correct? Any molecule can escape. Any molecule can escape. No, that's wrong. Only the molecules with enough energy. Only the molecules with enough energy can escape from any part of the liquid. Nope. only from the surface of the liquid. This is the evaporation. Okay, only the most energetic molecules escape from the surface of the liquid. Okay. Hmm. Diagram shows a sealed gas cylinder with a movable piston. The piston is moved slowly downwards. The piston is moved slowly downwards. What happens to the distance? What happens to the pressure? Huh? What happens to the distance? Distance is the volume. Okay, distance between the molecules. What happens? It decreases. What happens to the pressure? As the volume decreases, the pressure increases. As the volume decreases, the pressure increases. 12 was C. Okay, 12 was C. 13 is B. As the volume decreases, the pressure increases. Hmm. A long, thin bar of copper is heated gently and evenly along its length. What happens to a bar? When you heat up a bar, when you heat up anything, what happens? It expands, it becomes longer, okay? It expands and becomes longer. Well, again, 13 is B, okay? Yeah, 14 again is also B. When you expand, when you heat up any object, any state of matter, solid or liquid or gas, it will expand. Hmm. Yeah. Diagram shows four examples of thermal expansion. In three of the examples, thermal expansion is useful. One of the examples, the expansion is unwanted. One of the expansions, it's unwanted. Which expansion is unwanted? Which of these expansions is unwanted? It's quite easy. Yeah. Yes. Hmm. Which of these expansions is unwanted? Hmm. Yes, definitely it is A. We do not want the expansion of the bridge. Okay. We do not want this. Hmm. Yep. We've solved this question before many times. The base of the pan should be, definitely should be what? A good conductor. And the handle should be a poor conductor. Good conductor and poor conductor. Hmm. Easy. Hmm. Question 17. Which two effects are shown? One and two. Hmm. One is, what's one? Could it be refraction? No, cannot be refraction. One is reflection and two is diffraction. When it passes through a barrier, when it passes through a gap in the barrier, yellow, when it passes through a gap inside a barrier, what happens? Diffraction, reflection, and diffraction. Yeah. Hmm. Which row correctly defines the frequency and the speed of a wave? What is the frequency? Hmm. Number of waves per unit time. Yes, number of waves per time. What's the speed? Speed is the distance traveled per unit time. Distance over time. Distance over. Yes, it is the speed. C. Okay. Question 19. What's the angle of refraction? Hmm. Angle of refraction. Yeah. Yes, it has to be D. Yes, it has to be D. The angle between the refracted ray and the normal. This is the angle of refraction. Yes, correct. Hmm. The diagram shows a ray of light. Which row gives the angle of incidence and is it a total internal reflection or not? Hmm. Which of these is the total, which of these is the angle of incidence? The angle of incidence, again, has to be between the ray and the normal. Between the ray and the normal. So it has to be Q. Okay, it has to be. Is this total internal reflection? Hmm. No, no. Okay, it is not total internal reflection. It can never, okay, it can never occur in this question. Why can't it ever occur in this question? Okay, because you're moving from air to glass. When you're moving from air to glass, the angle decreases. The angle decreases. So it cannot totally internally reflect. For total internal reflection to happen, you need the angle to increase. You need the angle to increase the angle of reflection, or sorry, the angle of refraction. You need the angle of refraction to increase. In this case, it will never happen. What is this ray? What's this ray? Is this total internal? No, it's not. It's partial reflection. Okay, this is partial reflection. Okay, partial reflection. So this is not total. Total internal reflection needs to happen. For example, if you're moving from the glass, okay, to the air. If you're moving from the glass to the air, it could totally internally reflect. Yes, but from the air to glass, never, never. Okay, it will never happen. Okay, total internal reflection will never happen. Okay, from the more dense medium, yes, if you're moving from the more dense medium to the less dense medium, total internal reflection could could happen if the angle of incidence is greater than the critical angle. Okay. Okay. So definitely question 20 is C. Hmm. Photographer sees his image as shown. What could X be? Very easy. To see his image, it has to be a mirror. Hmm. Definitely has to be a mirror. Hmm. Question 22. Visible light and X-rays. Visible light, X-rays, and microwaves are all components. Which statement about the waves is correct? Which statement about the waves is correct? Microwaves travel faster. This is wrong. X-rays travel faster. This is wrong. In a vacuum, microwaves travel at the same speed, okay, and have a shorter wavelength than light. Microwaves have a shorter wavelength than light. This is wrong. Okay. Actually, microwaves have a longer wavelength than the light. In a vacuum, X-rays travel at the same speed and have a shorter wavelength than the light. Yes, X-rays have shorter wavelengths than the light. D. Okay. What can transmit some types of transverse waves but not longitudinal waves? This is a really interesting question. Can transverse? Yes. C. Yes, this is correct. C is correct. Why is it C? Why is it C? Because the vacuum, okay, the vacuum can transfer. The vacuum can transfer um, transverse waves, which are the electromagnetic waves, but uh, uh, they cannot transmit the sound waves, which are longitudinal waves. Hmm. Vacuum, yes, whatever vacuum, sure, whatever vacuum in space or on Earth, you can have a vacuum chamber on Earth. Okay, in this vacuum chamber on Earth, you cannot transmit the sound inside this chamber. Okay. Hmm. What is ultrasound? Again, what is ultrasound? Sound waves that are so loud? No, too high pitched. Too high pitched. The frequency is above 20,000 hertz. Okay, above 20,000 hertz. What would be the least successful method of magnetizing? Again, magnetizing is removed. Magnetizing and demagnetizing have been removed from the syllabus. So 25 is cancelled. Okay. Um, which electric current? An electric current in a copper wire is due to the flow of charge. What are the particles moving? We definitely know that the only particles that move are the electrons. Electrons. Which row correctly shows a conductor and an insulator? Conductor and insulator. Conductor. Yalla. Iron. Insulator. Nylon. Yes. Hmm. Piece of cake. Yalla. Question 28. Hmm. Question 28. Initially, when P was at point X, okay, the reading on the voltmeter was 6 volts. When when P moves all the way to Y, when P moves all the way to Y, what happens? Okay, we need to find the total, yes, we need to find the total potential difference. Initially, the 1 ohm resistor had a total voltage of 6 volts. If you have a 2 ohm resistor, if you have 1 ohms, the voltage of this 1 ohms is 6 volts. If you have 2 ohms, then the total voltage would be 12 volts. Why is it 12 volts? Because it's directly proportional. Okay, if you have 1 ohms, the voltage would be 6 volts. If you have 2 ohms, then the voltage would be 12 volts. Most of you would go on and choose C, which would be wrong. Why? Because I want the voltage of both of them. I need the potential difference of both of them. I did not say I need the potential difference of the 2 ohms alone. No, I need the potential difference of both of them together. So the potential difference of both of them together would be 18 volts. 12 plus 6 would be 18 volts. Okay. This is the potential difference of both of them together. What is the unit of EMF, electromotive force? Quite easily, yes, it is the volts. Um, Question 30. Which circuit contains, I still have problems with 28. Again, question 28. Very simply. The potential difference of 1 ohms is 6 volts. Oh, he said the reading of the voltmeter is 6 volts when it is connected to X. We know we know for a fact that whenever you increase the resistance, the potential difference also increases. Whenever you increase the resistance, the voltage increases. So whenever you increase the resistance, okay, the voltage increases. It increases directly proportional, okay? It is directly proportional. Whenever you increase the resistance, the voltage increases with a directly proportional ratio. Okay, so 1 ohms, 6 volts, 2 ohms, it has to be 12 volts. What did I do? Cross multiplication. What did I do? 6 times 2 divided by 1 would be 12 volts. So the potential difference of the 2 ohms is now 12 volts. What's the potential difference of both of them together? Okay, you need to just add them up. 6 plus 12 would be 18 ohms, 18 volts. That's it. Okay, that is it. Question 30, which circuit contains a fuse? Quite easy. The only circuit that has a fuse is C. The only one with the fuse is C. A student sets up circuit with a gap XY. Okay. He needs to connect a component to enable her to vary the brightness of the lamp. How can she vary the brightness of the lamp? How can she vary literally a variable resistor using a variable resistor, which would vary the current, it would vary the resistance of the circuit. Yes. Okay. Using a variable resistor. Yeah. 32. We have two resistors, R1 and R2. They are both connected in parallel. What's the resistance of the parallel combination? Whenever we have a parallel combination, what happens to the total resistance? Yes. Yes. It has to be less. Okay. It has to be less than either R1 or R2. So for example, if R1 was 5 ohms and R2 was 100 ohms, the total resistance has to be less than 5 ohms. Are you required to measure or to calculate the total resistance? No, you're not required to calculate the total resistance, but you just need to know that the total resistance would be less than either R1 or R2. That's it. Hmm. Circuit breakers and fuses are devices used to protect a circuit from overloading. Which statement? Hmm. Which statement correctly describes the difference between a circuit breaker and a fuse? The only simple difference between a circuit breaker and a fuse is that the fuse needs to be replaced. A fuse melts. A fuse melts. So whenever a fuse melts, you need to buy a new fuse and replace it. But the circuit breaker, you don't need to replace it. You can just switch it back on. Okay. Circuit breakers can be reset if they operate, but fuses need to be replaced. Okay. It's A. Fuses need to be replaced. Why might it be dangerous to use an electrical appliance in damp conditions, in wet conditions? Okay. In damp conditions, this could cause an electric shock. You could get electrocuted. You could get electrocuted. Yes. Hmm. Which diagram shows the magnetic field around the straight current carrying wire? Straight current carrying wire. Using what? How can I find it, يا شباب? How can I find it using the right hand rule grip? Okay, right hand rule grip. Using your right hand, okay, the thumb would be directed towards the right, okay? Thumb, because the current in this question is going to the right. So you have the thumb going to the right. If you close your fingers, if you close your fingers towards you, if you close your fingers towards you, they would create a magnetic field around the wire, which is directed, okay? It is directed towards you as well. Again, your thumb is moving to the right hand. Your thumb, your right hand rule, using your right hand rule, not your left hand rule. Again, most of you have used your left hand um, rule, which is wrong. You cannot use your left hand in this question. You have to use your right hand. The right hand, the thumb is moving towards towards the right. Why? Because the current in this question is moving towards the right. When you have the current moving towards the right, if you close your fingers, the other four fingers, if you close the other four fingers, they will create a magnetic field which is directed towards you, which would be A. B and D are wrong. B and D are definitely wrong. C would have been right if the current was in the opposite direction. If the current was in the opposite direction, the thumb would be going to the left, okay? And you close your fingers. When you close your fingers, the direction would be in the opposite direction. Okay? It would be the direction of the magnetic field would be in that direction. Yes. Okay. Okay. Yeah. Question 36. When wiring a house, it's important to use the correct cables. The current ratings of four different cables are listed. All four cables are used in series. Which cable is most likely to overheat? Which cable is most likely to overheat? Quite easy. Yes. Which cable is most likely to overheat? To definitely be hmm, uh, the 6 amperes. Okay. Why would it most likely to overheat? Because this cable can only withstand up to 6 amperes. But what happens if 10 amperes pass through this cable or 20 amperes pass through this cable? What would happen to this cable? It would overheat. It would melt. It would cause a fire. Okay. So this cable is the worst cable, okay, is the worst of these four cables. Why? Because it can only withstand currents up to 6 amperes. What happens if a larger current, that's the question, what happens if a larger current passes through this cable? It will overheat, okay? He said that, okay, 6 amperes, 10 amperes, 15 amperes, these are all, okay, these are the ratings of the cables. What do I mean by the ratings of the cables? I mean that these are the maximum currents that can pass through these cables. Currents above these ratings would cause these cables to melt, would cause these cables to overheat. Okay? ماشي. Yep. 37. A very important experiment improved scientists' understanding of the structure of matter. The experiment involved alpha particles being fired at thin gold foil. What happened? What happened? All of the alpha particles were absorbed? Nope, this is wrong. All of the alpha particles were unaffected? Again, wrong. Some of the alpha particles were attracted by the neutrons? Cannot be. Some of the alpha particles were repelled by the protons. Yes, we know that the alpha particle is positively charged and the proton is positively charged. So some of the alpha particles were repelled by the protons in the nucleus. Okay, some of them were repelled by the protons inside the nucleus. Okay. Hmm. Nuclide of a symbol 23, 11, and A, which statement there are definitely 11 protons. Yes, definitely 11 protons in this nucleus. Hmm. Question 39. The half-life for lead is 52,500 years. A sample of lead produces 800 counts per second. How long, how long will it take for the count rate to drop to 100 counts per second? What did I do? All I did was 800 divided by 2 was 400. Divide by 2 again, 200. Divide by 2 again, 100 counts per second. This took how many half-lives? Three half-lives. Three half-lives times each half-life. Okay. 38 was A. Okay. Each half-life was 52,500 years. So you just multiply 3 times 52,500. This would be 157,500 years. Just multiply, very simply multiply them. 3 half-lives by 52,500 years. Okay. Question 40. Why is a thick shield, okay, yes, why is a thick shield made of lead needed to protect people from sources of gamma rays? Okay. Why is it needed? Gamma is strongly ionizing. No, it's not strongly ionizing. Gamma is weakly ionizing and so not very penetrating. Nope. Gamma is weakly ionizing and very penetrating. So it is D. Question 40 is D. Okay.